Good day everyone, it is a great privilege to introduce to you about a device called Articulated Robotic Arm using Omron PLC. After the onset of the pandemic, the implementation of online class has been the new norm among schools. Together with my group mates, it has been a rough journey on how we came up with this idea, especially that limitations regarding virtual class such as slow internet connection have caused downturn to widen our knowledge about PLC. However, we are eager to learn despite of the challenges, and we are so thankful to our approachable advisor and our very own university for giving us the chance to experience this hands-on activity that will eventually help us in the near future. Now, let me officially introduce you about a device called Articulated Robotic Arm since it has different uses. It does not only have a rotary actuator but it also has a linear actuator which can use to extend, retract the arm, additional features of this robotic arm that performs gripping of fingers when one picks and places things. And also we have limit switches, which is very important in our device in terms of safety fuses. Because sometimes sensors can't be trusted and there's a possibility that sensors will malfunction. With that, limit switches makes our device unique. And with the help of Omron PLC software and a miniature model of robotic arm banded together to form an apparatus which is our device, and it is named Articulated Robotic Arm using Omron PLC.
Here we are with the steps on how we create the project.
First, preparation of all the tools and materials needed in the assembly of the articulated robotic arm using Omron PLC. Second, based on the perspective design, the researchers conducted layouting on the chassis of the articulated robotic arm using Omron PLC. Third, cut and weld the accurate length of the angle bar in rectangular for the framing of the automated robotic arm, based in a technical plan. Fourth, form and polish the whole body of the articulated robotic arm. Fifth, spraying the miniature model of the robotic arm. Sixth, install the base of the arm and wiper motor. 7. Install the first linear actuator for the first joints of the arm and also cut the fiber for the body of the arm. 8. Install the second linear actuator for the second joints of the arm and also cut the fiber of the body of the arm. 9. Install the third linear actuator for third joints of the arm and also the cut fiber of the body of the arm. 10. Install the fourth actuator for the joints, which is the claw of the robotic arm. 11. Installing the sensors and limit switches in the miniature model of a robotic arm. 12. Mounting the electronic equipment in the exterior casing of the articulated robotic arm using Omron PLC. Mounting the electronic equipment in the interior casing of the articulated robotic arm using Omron PLC. And lastly, testing the wholeness of the articulated robotic arm using Omron PLC.
Of our device.
Powering on the simulator. The articulated robotic arm using Omron PLC was connected to 220 volts alternating current AC, turned on the circuit breaker and the main switch to provide power to the computer system, and 12 and 24 volts direct to current DC, power supply to provide power to PLC, HMI, light indicator, DC electric motor, and linear actuator. Interfacing and operating the device. Articulated robotic arm using Omron PLC was equipped with computer system with Windows 7 operating system that serve as the storage of software. The CX programmer and designer was used to create a program in PLC and HMI.
Good morning. Here we are the steps in making ladder diagram. Diagram manual programming using Omron PLC. First, install a CX programmer software application on the monitor. Second, open the software. Third, create new file. Fourth, click PLC type and choose CPU1A and click CPU type, choose N40. Fifth, create a rungs in every axis and create a contact. 6. Proper addressing of input and output is a must. 7. After making the ladder diagram, in order to see the connection, you have to simulate. First, choose simulation, then click the work online for checking and addressing if there is no error and warning. 8. Exit simulator if there is no error and warnings. 9. Choose program, then click compile all programs. 10. Choose PLC and click work online. Then, last, 11. Transfer to PLC.
Hello everyone, since the program of the CX programmer is done, we must address it in a proper addressing. Since the PLC input terminals and the push button is an input device, we must address it. And the robotic arm is an output device. Push button, input. Sensors is an input. Robotic arm is an input device. And then the pilot light is also an input device.